Hello again, it's Mr. Pete, your YouTube shop teacher. Welcome back, and this is part 2 of a 2-part video, and I hope you have watched part 1, which would be number 721, tip 721. I'll flash that on the screen right now. And what we're doing in this video is we're continuing to make this little C-clamp. And I've already, in part 1, I showed you how to lay it out, and I milled both sides and drilled these holes. But there's still a lot left to do, and we have to make the screw also, and I'm not sure how much of that I want to show. The first part was 20 minutes long, and I'm not sure that I want this to be more than 20 or 30 minutes long. So let's see what our next step is. I got a real good finish, and part of that is due to the fact that this is a brand new 5/8 carbide end mill, just as sharp as can be, and it's a Morse brand. I don't believe I've ever used it before. Carbide is so heavy, isn't it? Now, I told you that if you use a 1/2-inch cutter for this, you might have a little bit on the edge here that didn't pick up, and that's why I used a 5/8 instead of a 1/2 inch, and that did change the radius here just a little bit, although it doesn't matter at all because that's strictly aesthetic. But just a little background on this, I did not design this. I had a friend that taught in La Crosse, Wisconsin in a junior college, and I went up there to visit him, and it was about 1971 or 72, and he showed me around the shop, and this was one of their projects. So he gave me a sample of it and the original blueprint. So this was designed by, not my friend, but another teacher evidently up there at La Crosse, Wisconsin, which is a really neat city right on the Mississippi River if you've never been there. So the next step before I saw out the waste stock is I want to put this angle on here, and we'll make it 45. I think that's slightly different. So I've already laid it out. I put some black on there, Sharpie I guess it is, and this type of angle is real nice to lay something out, but you don't even need to lay it out because I'm going to use this to set it up on the milling machine. Now that's almost too trivial to mill off. You can just saw it and put it on the abrasive wheel, or a belt rather, and take that off in a matter of 30 seconds. And this won't take long to mill, so let's go on over to the mill and take that off, and then we'll do the sawing. Okay, let's see how we'll set this up. Now you don't want to set it like this because that's just too much sticking above the vise. There's going to be vibration. I want to get it down low, even though I do not like staying so far away from the center. But again, using that little 45-degree triangle, I couldn't even think of that word a few minutes ago. I'm just laying it in there like this, getting it down as low as I can. Tighten it. I'm ready to mill that off. I don't think there'll be much vibration because it's already a pretty massive chunk of iron. Yes, I know this setup is a little sketchy, and I would be well advised to take another piece of stock the same thickness and having it clamped in this end to keep the jaws from springing a little bit, but it's such a light cut. But again, I don't like that distance, but let's give it a try anyway. Okay, all that to do for nothing. That was simple, and there was no vibration, no nothing, no drama. See how nice that turned out? Now, I did take a few minutes before, and I removed all the burrs. Maybe I said that already. Softened the corners, every little corner, and I got some more of that to do. But the next thing I want to do is I'm going to go out in Studio G and saw this out fairly close to the line, but leaving a little bit of material left to machine down to the line. And there's nothing more boring than watching somebody use a bandsaw, so I don't think I'll show any of that. But if you don't have a bandsaw, yeah, that's right. Okay, that was about 5 minutes of sawing, and it worked great with a nice sharp blade, but it's always difficult to make your corners here. But anyway, I managed. So I'm sure there's some of you are going to say, I do not have a bandsaw, I'll just mill that all out. And go at it if you want. Let's go to the milling machine again. This is a 1/2 inch diameter end mill, so it'll match the 1/2 inch radii in these corners. Now we can't put it in there like this because we are going to hit the vise. So it's got to go in like this, and I really do not like that because it's pinching a little bit probably. So anyway, it's on 1 inch parallel, and at some point as I mill, I probably will have to jockey the parallels around so that they do not get hit by the cutter, but yet still not support the work, but maintain the spacing. Okay, I took a preliminary cut. Now I'll make another pass to the line. Okay, that turned out too good to be true. Don't take it out till you're sure you're done. And now it's time to drill and tap the hole, and that's a 3/8/16 thread, which means we will tap at 5/16. Now I'm going to use, and the layout's already been done on there, remember? You know, from the other video. But in fact, what I'm going to, and you can use that, that's just fine, but not as accurate as an edge finder. Maybe that's overkill, but I will find both edges, and using the digital readout precisely locate where the hole is to be drilled, and then center drill 5/16 and tap using a tap guide. You want this hole to be drilled and tapped perfectly straight. Now yes, you can do it on a drill press, but this is more foolproof. And first the center drill, and yes, the work might flex a little bit, so just take it easy. It could be supported here, but I think I'm over analyzing. And now a 5/16 drill, which is the tap drill size. Did you see the work vibrating a little bit? Now when I edit this video, I see things that I do not see at the moment. So, and it won't hurt anything, but it probably flexed, and I think it vibrated. Let me show you a cure-all. Using another drill press vise in this manner, and the vise is up against the Bridgeport vise, and then just tighten this, and that can absorb the vibration, and it will prevent the C-clamp from pushing down. I should have done that, but now you know another possibility. All right, now let's tap that hole. This is a 3/8/16 taper tap. Always use a taper tap if you can. And is the work getting twisted? Probably a little bit, but let us remember this is just a C-clamp. I think I'll use a little bit of this anchor lube, and you can get this at KBC Tools. Quite an excellent product for tapping and other metal cutting operations. That tap is getting dull. I'm changing taps. Okay, it's a brand new tap with some anchor lube on, and let's see if that's any better. All the difference in the world. Now when you run into dull taps, throw them away. You cannot sharpen them, and they will just haunt you and and aggravate you in the future. So get rid of them, especially if you're 81 years old. I know you're going to say, hey, that's a perfectly good piece of high-speed steel. I'll use that someday. No, you won't. All right, run her all the way through. On the abrasive machine, let's round these corners just a little bit. You can do it with a file also. And these should be rounded or broken just a little bit. I'll try that on here, but I think it's a little bit too wobbly. Let's see what happens. I like to use brake cleaner or alcohol to remove the bluing. I know I said bluing, but I guess I meant redding, or actually I meant Dykem layout dye. Now why it says blue here, I must have put some red in a blue container years ago when I was still in my prime. Okay, if you want to take any emery cloth and clean this up further, feel free. I'm not too much on finishing like that, as you well know, but this is essentially done. Now it's time to make the screw, and I'm really hesitant to show this at all. So I think I'll make it extra credit if you do not want to see how I make the screw, because I've done that kind of work in many, many other videos. For those of you that are perfectionists, if you want to double check yourself and see how accurately you made it, you know, in those three directions, just challenge yourself. Yeah, if you're within 10 thousandths, that's plenty good, especially for using layout lines rather than the digital readout. But it does look pretty good, if I dare so say so myself. It would look better if I rounded that a little bit more, but no, it's done. Well, you know, I had full intentions of taking this project out and cutting the thread and turning it down on my new South Bend green lathe, but it is raining out and it's cold, so I'm just going to stick to the warmth and sanctity of my basement. And I've already got 3/8 or 1/2 inch diameter stock. I will be turning it down to 3/8, 4 inches long, 3.5 inches of thread, and we're going to turn it down a little bit at the end for the swivel. And I'm going to rush through this real quickly, and the threading will not be done, as I said before, with the single point method, but with a die under power. Okay, let's see how this cuts. Okay, this is my final pass, and I need to take it to 375, which is 3/8, but when I'm threading with a die, I like to go 2 or 3 thousandths under that. And I'm 374. That'll do. My intentions were to power thread by this method with the 3/8 die in this die holder, but then I realized that I have a limited depth of travel here. I can put about 2 inches of thread on, but not up to my layout line. So what is plan B? And by the way, this is on about a 2-foot piece of rod, so I will have to cut it off in order to use it in plan B. Okay, here's plan B. The work is held in the Jacob's chuck in the tailstock, and the die will be held in the headstock chuck. But if you put a die like this in here, it's hardened and the jaws are hardened, it's probably going to slip. So I like to use this little hexagonal device holding my 3/16 die, and you know that won't slip, but will this slip? I hope not, and remember, plenty of oil, back your slow speed. Yes, are we having fun yet? Is everybody happy? Okay, the screw fits nicely. So, one more thing, I need to turn down the end of this to accommodate the swivel, but I think I'll make the swivel first, and that will be made out of 5/8 diameter stock, just a tiny little piece of it, and again I'm going to rush through that. Okay, we've got 5/8 stock in the chuck, a center drill, so I've already faced it. I will center drill it and then drill 3/16 about 3/4 inch deep, and I'm not going to show that. And next, 5/16 drill, and I'm going to go about 5/16 deep. Continuing with the swivel, that's a 45-degree angle on there that I'm going to produce right now. It's going to be very awkward. I'm feeding with the compound already set at 45 degrees. Okay, there's the swivel. You see it's been counterbored. We got the angle on there, and you can make this to any design you want. It's a 3/16 hole, so now I'm going to take this, and I won't show it. I'm going to turn down the end of this to 3/16 diameter, and only about 1/8 of an inch long or so, maybe a little longer than that. Okay, I gave you an incorrect measurement. This should be 3/16 diameter and about 300,000, that is 5/16 long, such that when you put the swivel on like this, you can see the center drill mark, and we will be swaging that over. That is, take a center punch and swell it so this can't come off, and that has to be done after assembly, and I'm not going to show that because it's always a struggle. Couple more things now. This is too long, so I'm going to cut it off on the line and face it. This should be about 3/4 long, give or take. And then a cross hole drilled for the handle, and that's to be 3/16 diameter or 13, is what I wanted to say. And I'll be using the Heinrich cross hole jig so I get it straight. Now, you won't have one of these, so maybe drill that hole in the milling machine or something so that you get it truly on center, or it will look like heck. Okay, the end is faced. I've chamfered it. I drilled the 3/16 hole. This is 3/16 rod, and I got a pretty good fit here. So what I did is upset it a little bit in the middle here. That's not going to show up, with the chisel, so that I can just tap it as such. A little more. Looks pretty good. Now the alternate way that we did at school, but it's, again, it's a half-a-day project in itself, is to take 3/16 stock, thread both ends 10/24, tighten hex nuts on there, and grind them off round. That was a big problem at school. More darn kids got hurt on that. Minor injuries, of course. Well, the only thing left to do is to go ahead and assemble the screw in here, and after assembly, put the swivel on and upset it. Okay, we got a center hole there, remember. Put the swivel on, and now I'm going to put this in the vise, and for best results, use a Starrett center punch. And I'm going to punch that, in a couple different directions. And the word I was looking for, I'm going to flare the end of it, such that the swivel will still spin, but yet it will not come off. I won't show that. That'll be a nightmare for me. Okay, as usual, I made a big deal out of flaring that, and it just took 3 taps of the hammer. You won't be able to see that, but see, it doesn't come off, but yet it will spin freely. The job is done. Now, for those of you perfectionists that want to clean this up a little bit, or surface grind it, which I do not recommend, but use some abrasives if you want. But I got such a good finish because of good tooling that there really isn't anything left to do as far as I'm concerned. What do you think? Okay, we went from a concept here, the model, the sample that I had. There's no drawing, and we cut the stock, and we removed everything that didn't look like a C-clamp until we ended up with this. I hope you enjoyed the video. Tell your friends. Please subscribe. and I'll see you in my next video. Leave some comments, please. So long for now.